Hello, in today's class of Electrical Circuits 1, we will talk about circuit variables. Circuit variables are usually the quantities we calculate when we solve a given circuit. The most two common circuit variables are the voltage and current, and there are other circuit variables also like power, energy, charge, etc. The voltage and current are called primary circuit variable because we can calculate other circuit variables in terms of the voltage and current. First, let's talk about voltage. In order to understand voltage, we need to know what potential is. The electric potential of a point is equal to the work done if we bring 1 coulomb charge to that point from infinity. Why is infinity relevant here? Because infinity is a universal reference of potential where the potential is 0. The unit of potential is volts, represented by uppercase V. So mathematically, if we do del W work to bring plus del Q charge to point 1 from infinity, the potential of point 1 will be V, which is equal to del W over del Q. In the limit, when del Q is infinitesimally small, the division becomes derivative and V is dW dQ. Here, remember that W is work done and Q is charge. Let's say we have a point 1 in space whose potential is V1. We have another point in space, point 2, with a potential V2. Now, we want to know what is the potential difference between point 1 and point 2. There are obviously two answers. Is it V1 minus V2 or V2 minus V1? The differences can be taken in two ways. So obviously, my question was not specific enough because a single question gives rise to two possible answers. To remove that ambiguity, we will be more precise in asking the question. If I ask, what is the potential of point 1 with respect to point 2? And if I call that potential V, V is equal to V1 minus V2. On the other hand, if I ask, what is the potential of point 2 with respect to point 1? And if I call that potential V prime, then V prime is V2 minus V1. So we understand a pattern here. When I say potential of point 1 with respect to point 2 is the reference. When I say potential of point 2 with respect to point 1 is the reference. So the potential of the reference is negative and the potential of the point whose voltage we want to find out is positive. So this is a long sentence to clearly specify what voltage or what potential difference we want. We will represent this same information in a mathematical compact way. We will use a pair of plus minus sign to represent which is reference and which is our point of observation by using what is known as reference polarity. So what is reference polarity? To refer to the first situation, the potential of point 1 with respect to point 2, we will assign a plus sign to point 1 and minus sign at point 2. This minus sign tells us that point 2 is our reference and plus sign tells us we are finding the potential of point 1 with respect to 2. So this potential difference V is the voltage of point 1 with respect to point 2. Similarly, if I consider V prime, which was potential of point 2 with respect to point 1, I will put minus sign on point 1 and plus sign on point 2. Okay. Now we always have to remember that to completely specify a voltage, we need to show both the value V or V prime and the reference polarity represented by a pair of plus minus sign. If we do not mention either the value or the reference polarity, the voltage specification is incomplete. Another point we also observe is that the voltage V prime is V2 minus V1, V1 and V is V1 minus V2. That means V prime is minus V. This is an important observation. If we reverse the reference polarity of a voltage, its value acquires a minus sign. Always remember it. This will be very useful in problem solution during later parts of this course. Okay, now let's talk about current. Current through a conductor is equal to the amount of charge that flows through the cross section of the conductor in 1 second time. The unit of current is ampere, which is represented by the letter A. Mathematically, if del Q charge flows through the conductor in del T time, the current I is del Q over del T. In the limit, when del T is infinitesimally small, the division becomes derivative. We also observe that in case of voltage. Now, the current has a specific direction. The direction of current is along the direction of flow of positive charges. In case of negative charges, the direction of current is opposite to the flow of negative charges. This current direction is called reference direction. Let's look at a conductor. A current I is flowing through this conductor. So this I is the value and the reference direction is from left to right, represented by the arrow. So to completely specify a current, we have to mention both the value I and the reference direction indicated by the arrow. Now, instead of choosing the reference direction from left to right, we could also choose the reference direction from right to left and call the current I prime. In case of voltage, we observed that if we reverse the reference polarity, the voltage gathers a minus sign. This is also true for current. When we went from I to I prime, we have reversed the reference direction. So I prime is equal to minus I. Again, we have to remember that throughout the course. Okay, next we talk about power. Power is the amount of work done per unit time or in 1 second. The unit of power is watt, represented by uppercase W. So if we do del W amount of work in del T time, the power is del W over del T. Again, in the limit, when del T is small, this division becomes derivative. Now in this equation, I divide by dq and also multiply by dq. That does not change anything. Now the first bracket dw dq is voltage and the second bracket dq dt is current. So P is VI. You already know this relationship that power is the product of the voltage and current from college. Okay, now let's consider a very simple circuit. We have a 12-volt battery which is connected across a 6 ohms resistance. I call the battery circuit element A and the resistance as circuit element B. Using Ohm's law, we can tell that the current through this 6 ohms battery, 6 ohms resistance is 12 volt divided by 6 ohms, which is 2 ampere. And in a resistance, the current flows from plus of the voltage to the minus of the voltage. So current is flowing downward. Now this is a closed circuit, a closed path, and current flows through the closed path. So if the current through the resistance is 2 ampere, the current through the voltage source is also 2 ampere, which we show here. Okay. So now let's calculate the power of element A and power of element B. For both the elements, the voltage is the same, 12 volt, and for both the elements, the current is the same, which is 2 ampere. So for both A and B, the power is 24 watts, 12 volt multiplied by 2 ampere. However, the nature of these two powers is not the same. In case of resistance, the element B is absorbing power. A resistance cannot supply power. A resistance can only absorb power. So we know that PB power is absorbed. However, a battery supplies power. So the power of the battery is 24 watt, but this is supplied. So both 24 watts, but one power is absorbed and the other power is supplied. Okay, so these two are opposite in nature. If we call one power positive, the other power should be negative. Okay, now the question is which power is positive and which power is negative? We are free to choose which one we consider positive and which one we consider negative. If we say power absorbed is positive, we have to treat power supplied as negative. On the other hand, if we say power supplied is positive, then power absorbed will become negative. To avoid confusion, we will adopt a convention. The convention is known as passive sign convention, and according to passive sign convention, absorbed power is positive. So we will follow a passive sign convention which says absorbed power is positive or supplied power is negative. Okay, so let's revisit the circuit of our previous slide. Here we could tell that PB was absorbed because resistance absorbs power, and PA was supplied because battery supplies power. So according to passive sign convention, PB is positive, PA is negative. We identified positive and negative power by considering the physical property of the resistance and the battery. Now let's consider slightly different circuit. We have again two circuit elements. The voltage between the circuit elements is the same, 12 volts. The current is also the same, 2 ampere. But now, instead of showing a resistance and a battery, I am showing two rectangles. When I represent a circuit element by a rectangle, it means that we do not know what type of circuit element the rectangle is. It can be a resistance, it can be a battery, it can be something else. We do not know. Now the question is, in this circuit, the bottom circuit, which power is absorbed or positive and which power is supplied or negative? By comparing with the upper circuit, we could tell that yes, PB here and PB here are the same, so PB is positive, and PA here and PA here are the same, so PA is negative. But if we did not have the upper circuit with us, then this logic will not work. We need to find out a more concrete argument to decide when is a power absorbed and when is a power supplied. Okay, conventionally power is absorbed when the current enters the circuit element through the terminal which is marked positive for the voltage of the circuit element. To calculate power, we need to know the voltage, that means the value and the reference polarity of the voltage. We also need to know the current, that means the value and the reference direction of the current. If the current enters the circuit element through plus of the voltage, then conventionally power is absorbed. If the current enters the circuit element through minus of the voltage, conventionally power is supplied. When convention says power is absorbed, we say that that reference polarity and reference direction satisfy PSC. So let's look at the situation again. In this case, we have a circuit element with voltage and current specified. In this case, we can see that the current is entering the circuit element through positive of the voltage. According to the paragraph above, that means power is absorbed and this voltage and current reference satisfy passive sign convention. So, what is the power? It is plus 24 watt because absorbed power is positive and PSC is satisfied. Now let's look at a alternate possibility. The current remains the same, but we have a voltage 12 volt across the circuit element where plus is on the bottom and minus is on the top. In this case, the current is entering the circuit element through minus of the voltage. If current enters through minus of the voltage, conventionally power is supplied and supplied power is negative. So what is the power? The power is minus 24 watt. And when the convention says power is supplied, we state that in this case passive sign convention is not satisfied. So you can see that our old formula P equal to VI does not work here. In the right circuit element, the voltage is positive, the current is positive, but power is negative. So where did this minus sign come from? To accommodate this minus sign, we will have to modify the formula P equal to VI. The formula that you learned in college, P equal to VI, is incomplete. We will unlearn it. And what is the new formula? The new formula is P equal to plus minus VI. When to consider plus sign and when to consider minus sign? We will consider plus sign when passive sign convention is satisfied. That means when current enters through plus of the voltage. We will choose the minus sign when passive sign convention is not satisfied. That means when current enters the circuit element through the minus of the voltage. Okay, next is when we assign a voltage and a current to a circuit element, how do you choose the reference polarity of the voltage or the reference direction of the current? We are actually free to choose the direction and free to choose the reference, as uh, the choice of the reference is a conceptual decision, and whether a circuit element absorbs power or supplies power, that is a physical reality. Our conceptual decision will have no effect on the physical reality. So no matter how we choose our reference polarity for voltage and reference direction of current, the final calculated power should be the same. Let's look at an example. We have a circuit element as before. The voltage across the circuit element is specified to be 9 volt with plus sign on the top. The current is 5 ampere flowing upward. So if I want to calculate the power for this circuit element, the current is leaving the circuit element through plus of the voltage. So passive sign convention is not satisfied here. We will use P equal to minus VI. Okay, so minus, the voltage is 9 volts, the current is 5 ampere, the power is minus 45 watts. This minus 45 watts tell us that this circuit element is supplying 45 watts. Okay, now in this diagram, I chose the current reference or current direction upward. I don't like it. I want to choose downward current direction. So I reverse the direction of the current, but we have already learned if we reverse the reference of the current, that will acquire a minus sign. So the 5 ampere before becomes minus 5 ampere here. The voltage is unchanged, 9 volt with plus on the top. Now we want to calculate the power again. If we look at the reference, the current now enters the circuit element through the plus of the voltage. So passive sign convention is satisfied. When deciding whether passive sign convention is satisfied or not, we never look at the value of the voltage or the current. We only look at the reference polarity of the voltage and reference direction of the current and see whether the current is entering the circuit element through plus or minus. In this case, plus, so passive sign convention is satisfied. We will use P equal to plus VI. So we start with a plus sign. The voltage is 9 volt. The current is minus 5 ampere. So the power again turns out to be minus 45 watts or 45 watts supplied. So in these two cases, our references are different. But because we used P equal to plus minus VI formula, we get the same result. Now we have two more possibilities. Let's look at those as well. In the third situation, I have decided to reverse the voltage polarity. I will put plus on the bottom and minus on the top. So because the reference polarity is reversed, the voltage 9 volt becomes minus 9 volts. Current remains the same. Let's recalculate the power. Now the current is entering the circuit element through minus. So passive sign convention is not satisfied. We will use P equal to minus VI. Okay. So P equal to minus, the voltage is minus 9 volt, current is minus 5 watt. We get the same results, minus 45 watts. There can be another possibility. I reverse the direction of the current again. I choose the current upward, and for upward direction, the current is plus 5 ampere. Okay. Now, in this case, the fourth case, the current is leaving through the minus of the voltage. That means current is entering through the plus of the voltage. In other words, passive sign convention is satisfied. So P is plus VI. We start with plus, the voltage is minus 9 volts, the current is plus 5 ampere, and again the power is minus 45 watts. So in all the cases, regardless of our choice of reference, we get the same power. This is a very important concept and we need to remember it throughout the rest of the course. So that's all for today. I will stop here and we will discuss about these topics in detail in our class where we will solve more problems. Thank you. Goodbye.